A single pulsing radio signal traveling across a star field toward a tiny, distant spacecraft. Slow zoom out revealing the vastness of space. Imagine sending a text message and waiting almost 2 full days just to know if it was delivered. Now, imagine the person on the other end isn't a person at all. It's a spacecraft, so far away that no human being will ever catch up to it. For nearly half a century, Voyager 1 has continued its lonely journey through interstellar space, carrying humanity's message into the galaxy. But today, something extraordinary is happening. NASA is making difficult decisions that could determine whether Voyager 1 keeps exploring or slowly falls silent forever. The race isn't against distance anymore, it's against time. Archival-style footage of the 1977 launch pad, a rocket lifting off, cutting to animated flybys of Jupiter and Saturn. Then, a match cut to modern mission control screens. When Voyager 1 launched in September 1977, nobody expected to still be talking about it in the 2020s. Its original mission was simple. Fly past Jupiter, visit Saturn, send back pictures. Mission complete. Everything beyond that was considered a bonus. Yet almost 50 years later, Voyager 1 is still operating farther from Earth than any object humanity has ever built. It has traveled more than 25 billion kilometers from our planet. At that distance, radio signals take almost an entire day to reach the spacecraft. Every command NASA sends is an act of patience. Every reply is history by the time it arrives. The engineers who control Voyager today weren't even born when it launched. Some of the people who designed it have passed away. Yet the spacecraft keeps flying exactly as it was built to do. Cutaway animation of Voyager's nuclear power generator glowing faintly with a slowly declining power graph overlaid. Cut to a metaphorical visual of a house during a blackout, rooms going dark one by one. Voyager 1 doesn't use solar panels. Out where it is now, sunlight is almost meaningless. Instead, it survives on nuclear power generated by plutonium. But that power source weakens every year. Not suddenly, not dramatically, just a little less electricity year after year for decades. That slow decline has forced NASA into painful choices. One by one, scientific instruments have been switched off, not because they were broken, but because there simply wasn't enough electricity to keep everything alive. Imagine living in a house during a blackout. First you unplug the television, then the microwave, and eventually you're deciding whether to keep the lights on or the refrigerator running. That's essentially what NASA has been doing with Voyager. Every watt matters. Tense mission control room visuals, warning indicators flashing on a console, a slow-motion animation of Voyager systems flickering. Cut to a clock ticking, representing the day-long communication delay. Earlier this year, engineers noticed something worrying. During a routine maneuver, Voyager's electrical system behaved differently than expected. It wasn't a catastrophic failure, but it was enough to raise alarms. If power dropped too low, Voyager's automatic protection system could begin shutting systems down on its own, and that's dangerous. When you're communicating across nearly a full light day of space, you can't react instantly. If something unexpected happens today, NASA won't even know until tomorrow. Recovering from an automatic shutdown could take days or even weeks. So engineers made a difficult decision before the spacecraft made one for them. A perfectly healthy scientific instrument was turned off. Not because it had failed, but because sacrificing one instrument could save the entire mission. It's one of the hardest realities of deep space exploration. Sometimes survival means letting go of something valuable. Close-up animated diagrams of Voyager's internal circuitry, highlighting small pockets of trapped electrical charge. Visual metaphor, hands searching between old couch cushions and pulling out loose coins. But NASA isn't giving up. Engineers are working on a remarkably clever solution. Over decades of operation, tiny amounts of electrical power have become trapped in parts of Voyager's aging systems. Individually, those amounts seem insignificant, but together they could mean extra months or even years of science. The team is testing ways to recover that hidden power. Think of it like finding spare change between the cushions of an old couch. One coin doesn't seem important, but enough coins together can buy you more time. That's exactly what NASA hopes to achieve. If the plan succeeds, some instruments that were recently switched off could potentially operate again. It's an extraordinary idea, trying to improve a spacecraft that was designed before the first personal computer even existed. Beyond the edge of home scene, wide cosmic shot of Voyager crossing a glowing boundary line, the heliopause, into deep, star-scattered darkness. Data readouts of magnetic fields and particles animate softly around the spacecraft. Voyager 1 has already accomplished something no other active spacecraft has. It crossed the heliopause, the invisible boundary where the sun's influence gives way to interstellar space. Everything it measures now comes from a region no human has ever visited. No astronaut, no probe, no rover, just Voyager. Its instruments are helping scientists understand magnetic fields, charged particles, and the environment between the stars. And when Voyager eventually goes silent, those direct measurements stop too. There is currently no replacement arriving there anytime soon. For years, perhaps decades, humanity will lose its only active explorer in interstellar space. A final wide shot of Voyager drifting alone among the stars, the golden record catching a faint glint of starlight. Slow fade to black, then the channel's subscribe animation. One day, perhaps in the early 2030s, NASA will send another command. The Deep Space Network will wait. Hours will pass, then another day, and eventually, no answer will come back. Not because Voyager crashed, not because it found something mysterious, but because after decades of pushing beyond every expectation, it finally ran out of energy. Yet even then, its journey won't end. Voyager 1 will continue drifting through the Milky Way for millions of years, long after every city on Earth has changed, long after today's civilization becomes history. The spacecraft will still carry humanity's golden record through the darkness, a silent messenger from a small blue planet, continuing outward long after its final conversation with home. If you enjoyed this journey into deep space, don't forget to subscribe for more stories about the universe, space exploration, and the incredible missions expanding humanity's horizon. Because sometimes, the greatest adventures aren't the ones returning home, they're the ones still traveling into the unknown.